Hi, welcome to Fantom Academy. Today we're going to be focusing on an interesting little smart contract here. We're going to be making a gumball machine. So consider a gumball machine in the real world. You can put gumballs inside. A limited amount of people are allowed to. It has an unlocking mechanism usually. You fill it up with gumballs, you insert a coin, and then you turn a crank. And out comes a random gumball. And this concept can be pretty much mimicked into a smart contract, where instead of gumballs, we're using ERC-721 tokens to represent assets in the blockchain. And then instead of using quarters or coins, we're still using coins, and in this case, a ERC-20 coin or token. So this way we have a fungible coin that can be used to purchase the gumballs, or in this case, ERC-721 tokens. And then the random dispensing mechanism, which we will power with a VRF, which is a verifiable random function. In this case, we'll use Chainlink VRF, and that will provide us with a decentralized oracle that gives us verifiable randomness. So yeah, let's get started and jump into this. I've already set up a contract here, a little bit of a project. We have a small contract here called gumballmachine.sol with some imports, a couple things here set up for the VRF, and then a bunch of empty functions that we'll fill in later. Then we have a package here that's got a couple of the dependencies that I like to use personally. We also have our Chainlink there and our Open Zeppelin contracts, and then a couple of hard hat dependencies just to make our quality of life a little bit easier and to help with some testing down the line. And then we have a hard hat config here. That's a pretty simple config. This one has it set up for a localhost mainnet and a testnet using a private key and API key that we'll put in the .env. And you can get the API key from Fantom scan, and that'll work on both the testnet and the mainnet. And then I've just got a couple of personal little settings set up here, just a couple of things. You really don't need all of that. Really just need to have your network set up properly, and then you should be good to go. So yeah, we can jump back into this. I've already set up the node modules. So we have our Open Zeppelin modules here, which has our contracts token. We have our ERC-20 tokens, our 721, and then we have our Chainlink in here as well. So that's already set up there. I'm gonna go ahead and explain what imports we have first. So we'll just go over what we have here, and then we'll start filling stuff in. So first we've got ownable for our access control, and address utility just for us to use for the message sender. We have a little bit of security here for some functions, whatever function we want to guard with a reentrancy. We have our token standards. We have an interface for ERC-20 tokens, safe ERC-20 for transferring, interface for 721, and then our holder utility so that our contract has the receiver function so that it can receive the ERC-721 tokens. And then we have our Chainlink contracts here for the VRF, which is the coordinator interface and the consumer base. And then the consumer base uses the VRF coordinator address of the chain you're currently using. So since we're using Fantom testnet, we'll use the testnet coordinator. And then there's the subscription ID. The subscription ID is, you'll receive this when you set up your subscription with Chainlink's VRF service. You'll receive an ID for your subscription, and then you'll be able to fund your subscription with Chainlink and add your contract address as a consumer of that subscription. So that way, whenever a random request is made to Chainlink's VRF, it will deduct this amount from your or will deduct the amount required to pay the fee for your random number request to Chainlink's VRF. So yeah, that's where we set that. And then we've got a couple of things here that we have already set up for Chainlink. So we're going to go ahead and set up Chainlink first, since it's something we can just get out of the way first. So on the Chainlink documentations, we have the configurations available. You can go ahead and check that out. And we've got supported networks here for the subscription method. Now we scroll down, we'll be able to find the different coordinator parameters. You can see the request confirmations, the max gas limit, and other configuration parameters here. So if we scroll down, we'll be able to find Fantom. All right, here we go. So Fantom's mainnet, you've got your link address, the coordinator address, different key hashes here that you can use. And then the max gas limit, 2.5 million, we'll make note of that. And then the minimum confirmations, the amount of confirmations that you need to wait before the VRF replies, basically, with its response. So all we really need here is from the testnet. Since we're using testnet, we're gonna grab the key hash, and then we'll just remember this number here for the max gas limit and the minimum confirmations. So we've got 2.5 million max gas and minimum confirmations of 1. So we'll go ahead and put this in here for the key hash. You can set these variables to be dynamic if you want, and all you really need to do is add a function to be able to change the variables, just like this only owner function down here. And that way you can update these variables as needed. For our use case, we're just going to leave them static and have them hard-coded into the contract, because this is only going to be used on testnet. These variables here, the key hash, the callback, gas limit, the confirmations, highly likely won't change for your use case for this contract. So you can leave them as they are. The subscription ID, I do suggest creating a new function for that, for only owner, just to change this ID in case you need to update it in the future. Since that's one thing that can change depending on your subscription that you're using. So if you'd like to change that in the future, it's always nice to be able to have an extra function there and to be able to change that on the fly with only owner. So yeah, that's what we have there for Chainlink's VRF. It's pretty simple. This information will be sent along with the request to the coordinator, which will get the random number, return it through this function here, the fill random words, not numbers, and we'll return a request ID and an array of the random numbers, which in this case they just call it random words, but it will be random numbers. And that's an overridden function from VRF consumer base v2. So this is required for VRF to work for Chainlink. So the way that this all is going to work is we have a few functions here. The insert gumball function is what users will use when they want to put their ERC721 tokens into the Gumball machine. The buy gumball function is all that a user will need to call to be able to randomly buy a gumball. This function will send a request to the VRF for a random number. The random number will be returned through the fulfill random words function, which is internal. And then that in turn will also call the dispense gumball function, which will use the random number to determine which asset is being distributed to the user when they purchase it. All that together makes the mechanisms of a gumball machine. It's pretty simple and pretty straightforward. And then we have, lastly, a owner admin function for setting the gumball price. If you want to update the price yourself, then you can go ahead and do that. So yeah, let's go ahead and get started, and we will set up all of the variables that we need, the mappings, any kind of structs that we need to set up, pretty much everything set up for the contract first, events and such. So we'll go ahead and get ready with that. Excuse me. I'm just going to take a drink here. All right, so we have 4 events here. One for inserting the gumball, one for buying a gumball, one when a gumball is dispensed, and then we're going to put one here in the set gumball price just to let people know when the price is updated. So we'll go ahead and add some events here. So we'll do gumball inserted, and that will return the address of the person who put the gumball in, the token address, and it will also return the token ID. And then we have another event here for purchasing a gumball. When a gumball is bought, it will give us the request ID that is sent from the VRF and the address of the buyer, which we will use later to catalog and make sure that the fulfill random words is using the proper address when dispensing the gumball, because the message sender for fulfill random words in this case will be the Chainlink VRF and won't actually be the person or the address purchasing the gumball. So this way we record that beforehand to make sure the right address is receiving the gumball or the asset. So we have an event for dispensing the gumballs. And we're going to give the token address. We're going to give back the token ID, the address of the buyer, the request ID, and lastly, we're going to return the random results. It's a long event there, but it'll give us a lot of information that could be very valuable yet later for any kind of front end, possibly, or just to decipher what's going on the blockchain with these functions. And then lastly, we have the price changed, which will just give us the old price, and the new price. There we go. We have our events, 4 events that will cover all the functions for this contract. So next we have a struct. We're going to put in the different structs that we'll be using here. In this case, we only have just the gumball and what goes into a gumball, basically. So for that, a gumball is going to consist of just a few things. It'll have an address, which is pretty simple, what an ERC721 token has, and has a token ID. And for our use case, just to add a little bit here, this can be used later, possibly, the contributor, the address that inserted the gumball into the machine. And then, so that's it for the structs. Next we're going to put in our mappings, any kind of mappings or arrays we're going to use. So we're going to make an array actually of this gumball struct here, and we're going to just call that gumballs. So we're going to take an array of that and make that public, and we'll call that gumballs. So now we have an array of different gumballs that we can use that will record our ERC721 tokens that are inside the machine. And then we're going to have a mapping of requests. Now, what this is going to be used for is just to record the address of the users that initially make the request. Since there's, like I said before, there's a gap between when the buy gumball function gets called by the user who's buying the gumball, or the address who's buying the gumball, and when the fulfill random words function is called by Chainlink's VRF. In this case, the transaction sender will be the user address, and this transaction sender will be Chainlink. So we want to make sure that we're able to get this address, and we'll record that by gumball, and later we'll pull that back out using the request ID. So that'll make it easier to retrieve the address of the person who's actually buying the gumball and make sure it goes to the right person. Okay, so that's it for that. Lastly, we have a few variables, and we have our pay token, which is, like I said before, the coins are going to be an ERC20 token. So we're just going to call that pay token. And then we need some variables for tracking a couple of things, a couple of global variables for the whole contract. So we're going to actually have 2 variables for total gumballs. And the reason for this is because, like I said before, there is a difference between when the buy gumball function is called and when fulfill random words is called back from Chainlink, which in turn dispenses the gumball. This all happens in one fell swoop right here. So you've got this initiates it, and then Chainlink will handle the rest with these 2 functions. So total gumballs and total gumballs left will iterate. One of them will iterate in buy gumball, and then the other will iterate from dispense gumball to essentially keep track of how many gumballs can be bought and how many gumballs are left to be dispensed. Since there is a little bit of delay sometimes, depending on how quickly the blocks are being handled, this could be delayed. So therefore, both of these numbers help us better keep track of how many gumballs are actually left inside this. So we're going to actually put gumballs left inside here and total gumballs and dispense, and that'll keep that all in line for how many actually exist. If we didn't put that in, then we would actually, or we might run into a case where users are able to buy gumballs that don't exist, and then when it comes to the fulfill random words, Chainlink will revert on the random number because it realizes there's no more gumballs to dispense, but it sold them since the gumballs, it thought there were more here. If we iterated it here, just say, yeah, it wouldn't work. So yeah, that solves that for us. So I'm pretty sure that's all we need there. We've got our gumballs, we have an array for them, an array for the requests, our pay token, a couple of things to track our gumballs here, and then we're good. And like I said, the gumballs are usually 721 tokens, and it's just it's a quicker way to say it too, actually. Just gumballs. So we're gonna go with gumballs. So that's pretty much it for that. And now all we need to set up, or not all we need to, but let's get into the constructor next. So we're gonna make some room here because we're actually gonna use quite a few variables for this, and clean this up a little bit to make this look a little better. And we're gonna add in a couple of variables here. So in the constructor, we're going to set the gumball price. This is where you will initially set this. We will set the pay token, the address of the pay token. So this can be any ERC 720 or any ERC 20 token rather, and that'll be used to essentially buy the gumballs. And we'll go ahead and set those here. So we'll just have those 2 right there. And then we will go pay token equals or is IRC. And then we'll do the address pay token. There we go. So that'll take the address of the pay token. Make sure we put 20 here. Make sure, since we're using multiple different token standards, we got to make sure that's all set properly. Let's see, pay token. We already have that declared here. There should not be an issue with that. So let's go ahead and check what the issue is there. See this pay token. I mean, pay token or pay token? No, pay token. And it's capitalized. So small little issues like that, we got to make sure. You always got to make sure that you have the right syntax. Once again, syntax is important. And then lastly, we'll set the gumball price. And there we go. So now we have the gumball price set in the constructor, and we'll be able to set the address of the pay token in the constructor as well. All right, so now we have the constructor set up. The all of our variables set up, our events, our mappings. Now we can get into the functions and start filling out this contract a little bit. So let's start from the top here, and we'll work with the insert gumball function. So this function is going to have a couple of requirements and is going to simply transfer the ERC721 token from the owner of the token to the contract of the machine. After that, it'll iterate a couple of our variables here, our total gumballs left, and then it'll catalog that information under the gumballs array here. And then lastly, it'll emit the event. So let's get started with that. Our first requirement is to make sure that the user inserting the gumball is actually the owner of the token. So we're going to check owner of, and we're going to do underscore token ID, since that's what we're using here. And we're going to make sure that's equal to the message sender. And if not, we will throw an error here saying it's not owner. And then our second requirement is we're going to make sure that the user or the address that's inserting the token has already approved the Gumball Machine to move the token. So is approved to actually use that token and transfer it around. So we're going to make sure is approved for all, message sender, and then for the operator, it will be the address of this contract. So there we go. And if not, like I said, it will throw a flag here, and that will be something like this actually should be here. We'll say the Gumball Machine address is not approved to transfer this token. Okay, there we go. So we have a couple of requirements there. Just make sure that the owner is properly set. They can properly transfer the token, or the contract is approved to transfer the token. And then we will go ahead and transfer the token. After we transfer the token, we'll be able to catalog that. So we'll go ahead and first we'll do safe transfer. We'll do safe transfer from, and from will be the token address here. So this is going to be a little bit required, a little bit involved. So ERC721 token address, since we're in turn using another one, and owner of token ID. Looks like that went outside of the brackets there. So, okay. All right, so the owner of the token ID, and then to address this, and it will be the this underscore token ID. So just to make that look a little bit better, we're gonna change up a couple of the formattings right here. I think this will look good right there. Probably owner of the address, the token ID, and we'll do it like that. Make that look a little nicer there. Okay, there we go. We'll just save transfer. Transfers the token ID, and then we will increment both total gumballs and total gumballs left, since this will increment, those will keep track of both. And then we're going to push the gumballs array. So we're going to do gumballs push. That will give us an empty entry in our array. And then we're going to go ahead and set the information for the array. So we'll do gumballs, total gumballs, and that'll be -1 to give us 0, since it will be at the 0 entry first. And then we'll do token address is _ token address. There we go. And we can go ahead and we can copy this part right here, and we can do this again, and we'll do token ID is _ token ID. And then one last time, contributor is the message sender. There we go. And lastly, go ahead and emit the event with the message sender, the token address, which is _ token address, and the token ID, which is _ token ID. And there we go. We have our insert gumball function. It's pretty simple. It checks to make sure that you're the owner of the token, that the contract, the Gumball Machine contract is approved to transfer the token. And then it will safe transfer the token from the owner to the address of this contract. It will iterate our total gumballs, push the array, and then catalog the information of that asset under the array. Lastly, it'll emit gumball insert, and there you go. Now we have gumballs that can be inserted inside this array using this struct, iterating these variables to make that all work. So next we have our buy gumball function, which will use Chainlink's VRF to get a request ID, and it will catalog that request ID as the message sender here, so that we have access to that address. And then it will remove one of the total gumballs left, and then it will emit an event. That event will let us know the request ID and the buyer. After that, Chainlink will pretty much take care of the rest of the process. So the only thing we're gonna require here, we're gonna have 2 requirements. We're gonna make sure that the total gumballs left is greater than or equal to 1, just to make sure that there's actually something inside. And if there isn't, we'll let them know that the gumball machine is empty. And then we're also going to transfer the pay token. So that's another requirement here. And we will use transfer from for that. So we'll do pay token transfer from, and we'll do transfer from the message sender. In this case, the user who is buying the gumball. It will send the funds to the gumball machine, and it will be the gumball price. If they don't have enough to pay the gumball machine price, it will let them know and you have an insufficient balance, or gumball machine not approved. Transfer from will throw that as well. So we don't need to use that, the only approved, or make sure that they're approved, since transfer from will revert if they haven't approved as well. So we don't need 2 requirements for that. So those are the only 2 requirements that we really need to buy a gumball. And after that, like I said, we're going to get the request ID. And the request ID is going to send a request to the coordinator. So we're going to take the coordinator, and it's going to request random words. And as you can see, it comes up with the information that we need there. So we need the key hash, the subscription ID, the request confirmations, the callback gas limit, and then the amount of words or random numbers that we're requesting. So in this case, we already have the key hash set, so that's good. For the VRF subscription ID, we called that VRF subscription ID. So we'll set that there. So that's good. And then we have minimum request confirmations. We have that set here as request confirmations. So that's good there. The callback gas limits, same number or same word there. So that's good. And then for the number of words that we're going to request, we only need one random number. So we're just going to put 1 there, and that'll be good for that. And we can fix the formatting there. And there we go. The request will be sent to the coordinator with the information that we give it, our subscription ID. The coordinator will use our subscription to automatically deduct link from the subscription and use that to fulfill the random number request, which will return back to the contract here. So that's all we really need to do for the requests to the coordinator, that is. But we also want to make sure that we have the requests cataloged here under the contract, because like I said before, when the VRF sends the random number back to the contract, the message sender won't be the user who's buying the gumball anymore. It's going to be the VRF. So we're going to make sure that the message sender is cataloged here using the request ID that was sent back from the coordinator. And we're going to put their address here in the request mapping. And then we will remove one total gumball and emit the gumball bot with the request ID and the message sender. That'll give us the information that we need for the event. And there we go. Now we have a way to buy the gumball. The gumball will send a request to the VRF. We'll make sure that the address of the message sender is recorded under the mapping here so that we can use that later to dispense the gumball to the proper person. So next we have the fulfill random words. Now, this is what runs after the Chainlink VRF essentially gets the random number from the decentralized oracle and returns it to the address, or returns it to the contract. So in our case, we're going to take that random number and we're going to get the modulo of the total gumballs and the random number to make sure that there's only a number between 0 and the max number of gumballs that gets chosen from. And essentially the way that we choose the gumball will be choosing a certain index of the gumball array. So if the random number, for example, is 2, then it will be the third index of the gumball array. Since the first index is 0, that's how that'll work there. So what we're going to do when the VRF returns the random number is we're going to take the result, like I said, and we're going to get the modulo of the result. And then we're going to make sure that the number can actually go to 0 in the case that 0 doesn't get rolled. So, or an exact number, perfect modulo number gets rolled, is the exact number of gumballs inside the machine. In which case, we're going to make sure that the result is lowered by 1. There we go. Yeah. So the result's going to be decreased by 1 to ensure that the gumball at the 0 index can actually be reached when the modulo is found. Since modulo can be 1 the max number modulo could be 1. In this case, our results can actually get the 0 index. So yeah. After that, we will dispense the gumball. We're going to use the request ID and the results as requested here. And that's going to essentially dispense our gumball, which will be in this next function here. So this all happens in one function call. The user calls by gumball, which gets fulfill random words called in turn by the VRF, which calls dispense gumball. So one function. It's pretty nice. It's pretty efficient. And dispense gumball is an internal function, so we don't need any requirements here. We already checked to make sure that the gumball machine wasn't empty, that the sufficient balance was met, and the machine was paid. So we really don't need any requirements in both of these functions. So we're just going to get right into it. So the formula, the way that the gumball machine will dispense these gumballs is, first we're going to take down the address and the ID of the gumball that wins, the random number. So let's just say, for example, the random result is 3. So it will take the 4th index of gumballs, essentially. That will be the winning number. So in this case, let's say, for example, there are 10 total gumballs and the winner was 4. In our case, gumball number 4 will be dispensed to the user who purchased the gumball, and then the information of the 10th gumball will be recorded into the 4th gumball place. So essentially swapping the last in line with the winning number. And then after that, the array will be popped by 1. So it will be, the last entry will be removed, decreasing the overall array length by 1, so that the array only has the amount of gumballs that exists in the machine. So it'll use that whole formula to dispense the gumball through the dispense gumball function. So it sounds a little confusing, but it's pretty simple when we actually use it in practice. So let me set that up here. First, we're going to get the dispense gumball address, the dispense address. So we already got our result here. This is our random number, and the result will be used to get the index of the gumballs. So result dot token address, and we've got that there. So now we've got the token address and then the dispense ID. Just 1 second. All right. So the dispense ID will be the token ID, essentially, of the gumball. And we'll get the result there, which again is the index of the random number that we received from Chainlink's VRF. And then we'll get the result again. And we're going to replace it with the last in line. So in our case, let's just say it was number 4. It would take gumballs, the array, if the actual random number was 4, then I guess it would be the 5th index. So it would have the 5th index of the gumball array, and it will take the last in line, which will be able to be grabbed with total gumballs, and will replace its data with the last in line. Now that the last in line is secured and replaced, and now we have the information of the winning address, or the winning gumball, we will pop the gumballs by 1. So that removes the last in line. Now that the last in line is now at index 5. And then we'll total gumballs. Decrease by 1. Now that that's good. Last, we want to transfer the token. We do that last, of course, just for best security practice. And we will do safe transfer from, like we did before. And like we did before, we will do it from the address of the asset. So we'll cast the IRC721, and we'll use, in this case, the dispense address. And then we will go owner of dispense ID, which will be, in our case, our address. And then we'll take the owner of the user who made the request from our request ID. Oh no, it's just request ID from our request array. And that's actually requests right there. There we go. Perfect. So that way we have access to that address again, since, like I said, dispense gumball is being called technically by Chainlink VRF. Message sender in this case will be the Chainlink VRF coordinator address. So we make sure we transfer to the correct address, which is the address that made the request. And last, it will dispense using the dispense ID right there. So we're going to make that look a little bit nicer here. Let's just do a little formatting, just clean this up a little bit. And there we go. We have our safe transfer that transfers the token. Now the token's been transferred. Last thing we need to do is just emit that the gumball has been dispensed. So we're going to use the dispense address for this, the token ID, the buyer, which is available through right here, the request ID, and then the random results, which was available right here, results. And all of that gives us all the information that we need to know what gumball has been dispensed. So there we go. Our dispense mechanisms, very simple, very straightforward, pretty minimal gas usage. Overall, the Chainlink costs will be, it's a fraction of one link to make a call. So just a couple of links should be enough to fund a contract for a really long time. You'll be able to make a lot of requests with a small amount of link using these formulas for dispensing. So that takes care of the dispense mechanism. We've only got a couple of things left to set up here, and then we'll pretty much be good to go. So we're going to set up the gumball price, which is it's a pretty simple function. It's just like most other functions that just change variables. We're going to take the old gumball price here, and we'll get that right there. We're going to make sure we have access to that. We're going to get the current gumball price, and we're going to make it into the new gumball price, which is what we entered right there. And we're going to lastly emit the gumball price changed, and we're going to put the old price and the new price, what the price is now. Or if we can just make sure we've got that set correctly, just in case, so that everything is set properly. All right, this way we emit the old price, the new price, make sure that's set up here properly, old price, new price. Awesome. So last, our fallback functions. Now these are just going to revert in the case that somebody sends either to the contract without stating So last we have the fallback functions, which is just a little bit of a guard just to make sure that in case users send any crypto to the contract directly, without calling a function, that it reverts and just lets them know that no function was specified. And this is with data. And then we're going to do pretty much the same thing over here for receive. No function specified without data. This way, if the contract receives any crypto that wasn't intended to be sent to this contract, obviously, since it's not a wallet, so crypto shouldn't be just dispensed into this contract, it will revert and send that back just to make sure that the users understand what they're doing there and to fix what they're doing. So that's it. That's pretty much all we need for the Gumball Machine. It's a pretty simple, straightforward contract. We've got a mechanism for inserting ERC-721 tokens, which can be any ERC-721 token that exists on the chain. Checks to make sure that it's the proper owner, transfers the token, iterates the gumballs by 1, which we have just a variable here to track that, sets up our array by pushing it by 1 and then inserting that information into that index and emitting an event. And then we have the by gumball function, which requires that there actually is assets inside the machine, and then requires that the user pays the machine the proper price. And then it sends a request up to the VRF coordinator, which gets the request ID and gets the request for the random number going. When it returns the request ID, we use that number to catalog the address of the message sender, reduce the total gumballs left by 1 because this request is currently in the works, and then we'll emit the request ID in the message sender that a gumball is bought. And that's all that the user needs to do right here. Call this one function, because the rest of this is called by the VRF. So after the request has been sent up, the VRF, it'll take just on Fantom, it should only take a few seconds for this request to go through and already send back to you. So you should already have your request back to you in just moments, really. Fulfill random words gets called by the coordinator and returns the request ID and the random numbers. This random number is then taken and we get the modulus of that to the total gumballs and ensure that the result can reach all the way from 0 to the max number of assets in the machine. After it gets the proper random number, it calls the dispense gumball function with our request ID and our result. That in turn gets the winning token, which is the dispense address and the dispense ID, using the result at the index of the gumballs array. And then it takes that winning number and it replaces its information with the last in line in the array, so that when we remove the last in line, it's still recorded here under the winning number, reducing the total gumballs by 1, and then finally transferring the asset from the machine to the winner, and then emitting the gumball dispensed event. And that's pretty much it. That's a Gumball Machine turned into a smart contract using ERC-20 tokens for coins, using ERC-721 tokens for assets for the gumballs, and using Chainlink VRF for random chance of choosing which gumball gets dispensed. You can update this a bit if you want to add ERC-1155 tokens, for example, to be available as the gumballs. You can make it So instead of having the machine pre-filled with assets, it can be pre-filled with addresses of the collections for ERC 721 contracts and be pre-approved to call the minting functions of those contracts. In turn, that would create a gumball machine that's essentially everlasting, that can mint however many tokens the addresses that are registered to it are able to mint, really. And if there's no limit on some of those tokens, then there won't be any limit on this machine. So it's a pretty simple and interesting way for asset distribution. You can fill it up with whatever assets you really want, and users have a way to randomly purchase those assets. And in our case, they're referred to as gumballs. So in the next video, we're going to get into the scripts a little bit. We'll create some deployment scripts. We'll deploy that to the test net, and we'll mess around with that a little bit and see how that actually functions on the test net. We'll get some mock ERC 20 tokens and ERC 721 tokens, and we'll deploy those as well to use as our mock tokens. And then after we've tested it out and seen how the contract functions, maybe we can make a little bit of a front end and make it working real simply with something like MetaMask, so that users can just click one button to insert a coin, essentially, to purchase one of these assets. So yeah, we'll expand on this and make it a little bit more interesting. For now, this is a very simple Gumball Machine contract, or Gumball Machine turned into a smart contract. So I hope you've enjoyed this video here, and we'll get more into the details in the next one. Hi everyone, hope you've been enjoying this lesson so far. So I realized after recording this video that I made a slight mistake in the part where we take the random number and mod it to get the random result. So let me walk you through the error, and then I'll show you the corrected code. So originally I had this uint256_result is random words, and we took the 0 index and we did a modulus the total gumballs, which is fine. But then I went on to decrement the actual result by 1, which is not correct. So I did this here, result greater than or equal to 1, and then we decrement. And then of course we had the event for the request ID and the result. However, I realized that the if statement checking for results is greater than or equal to 1 is actually unnecessary. The purpose of the modulus operation is to get a random number within the range of 0 to total gumballs minus 1. And since Solidity uses 0-based indexing, the result of the modulus operation is always going to be within this range. So there's no need to further adjust it by decrementing result by 1. So here's the corrected version of the code. So as you can see, I removed the if statement, and the code is now simpler and easier to understand. The corrected version will still give us a random index within the valid range, and it's actually a more efficient way to achieve the same result. So I apologize for any confusion. Hope this clears things up. If you have any questions, please don't hesitate to reach out. Thanks. Happy coding.